Hello and welcome to the Erlang Solutions webinar. My name is Mladen Milikcic and I'm the VP for the EMEA region here at Erlang Solutions. Today's webinar represents a continuation of a series of webinars we have been running across topics of interest in the world of Erlang and Elixir, and dealing with solutions based on these programming languages. On this particular occasion, we will be hearing about Vidyo, a video communication platform as a service, which is aimed at providing high-quality video chat APIs. Now, with the help of Vidyo, developers can easily embed multi-party video into their own mobile, web, or desktop applications quickly and seamlessly, and most importantly, with no prior video knowledge required. As with any live event, if anything goes wrong, then please excuse us. We'll try to rectify any issues as the webinar progresses. But to start telling you a bit about Erlang Solutions, we are a products and services orientated company fully devoted to the Erlang and Elixir programming languages. We work with organizations and individuals using Erlang and Elixir, helping them evolve these languages and supporting people and businesses using these technologies. We are headquartered in London. We have offices in Stockholm, Krakow, Budapest, San Francisco, and Buenos Aires. Our projects span industries and the globe itself, and we develop Erlang and Elixir-based products. Some of those include MongooselM, our open source messaging platform that we'll mention today, Wombat OAM, which is our monitoring and management technology for Erlang and Elixir systems, and Megaload, our load testing technology. Now, I'm really pleased to say that our speakers today are Nic Reid, the Senior Vice President of Product Management at Vidyo, and Michal Slasky, the Managing Director of ESL Krakow office, who will tell us a bit more about the challenges Vidyo faces and the benefits it strives to provide. Please allow me to finish by saying you are most welcome to post questions throughout the duration of the webinar by using the chat facility available on the webinar's interface. Our speakers, Nicholas and Michal, will answer as many questions as time allows at the end of the webinar. If any questions do go unanswered, then you're welcome to raise them via email by using the following address, webinar@erlang-solutions.com. Now, if you're interested in learning a bit more about Erlang or Elixir or technologies based on these languages, then you're welcome to contact myself directly. My email address will be available on these slides, and following today's presentation, you can acquire that as well. Now, I would like to hand over to Nicholas now, who will be glad to start the webinar off.
Thank you very much, Mladen, and thanks again for the opportunity to come and speak with your audience about the Vidyo IO service. And I hope over the course of the next half an hour we can, tell you a little bit about what we're doing from a multi-party video collaboration standpoint, and why MongooselM and more broadly Erlang Solutions were such an important part of that service and getting that service to market. So really, our history as a company, Vidyo Inc. is really multi-party video collaboration. We've been around for just over 10 years now. And we've been working on trying to bring multi-party video collaboration to desktops, to mobiles, to all kinds of form factors with the highest possible quality over whatever networks you might find yourself connected to. They can be very poor quality networks. It can be very, very high bandwidth networks, and we'll take advantage of both, all forms. So some of the I suppose the important things, just to give you a little more background about Vidyo, in particular our technology, which is a nice way of getting into the conversation around, why we needed to work with something like MongooselM. We're specialists in video media and real-time video media kind of transport across networks. So being able to have multi-party video across unreliable networks with low cost, and still be able to tolerate delay. We wanted to be able to scale massively. We need very, very highly reliable infrastructure, and we now have a global footprint. The intent was to create a global footprint, many points of presence, multiple locations. We've got 10 to 15 different points of presence at the moment, and that's going to expand over the coming months. So we knew that that was one of the components that we needed to think when we're building our next generation infrastructure. We do a lot of work around dynamic network optimization. So we are very aware of network resilience and or doing things in our protocol stack to be able to affect network error resilience and cover up errors where possible. We do a lot of we kind of make improvements to the bandwidth consumption of streaming video using some unique characteristics of our video routers. So we can, if you like, bundle up multi-party streams and send them between routers in efficient ways. So if you've got hundreds of, or perhaps even thousands of users in a given conference, we're not sending a full mesh of the media everywhere. So that's some capabilities in our video router. We optimize the streams in real time. The video router optimizes those streams in real time based on the endpoints that people are using. So for instance, there's no point sending full 4K 60 frames of resolution to a mobile device, because it's never going to have the pixels to consume that. It's never going to have the bandwidth to be able to take that amount of bandwidth, of that kind of resolution. But if you're in a fancy boardroom in the middle of Manhattan and you've got very high resolution screens, 4K screens, and a gorgeous camera and lots of bandwidth, then maybe in that situation it makes sense to send 4K and very high frame rate in terms of resolution. So it's all about trying to adapt the multi-party video to the right footprint. And we spend a lot of time thinking about optimizing for exceptional quality over low bandwidth. And in terms of the endpoints that we support, as I mentioned, any mobile kind of platform you can imagine, including Android on things like x86 and which is an unusual combination, but we're seeing that occur in various form factors. So just about any kind of platform, we have very, very broad support for all sorts of different endpoints. We support a range of different multi-codecs, everything from VP8, VP9, H.264, H.265, and all the kinds of high-quality video codecs that people are using out there. And it's really a very broad brush service. Now, why would you want to do multi-party video conferencing? Or video collaboration? Why is this a useful thing to have? And obviously there are some obvious ones. The obvious one is the sort of the everyday office collaboration. You want to, we just heard that Erlang Solutions has offices dotted across Europe. It would be very useful for them to be able to collaborate across those offices in a sort of an easy to use desktop mobile kind of form factor. And that's certainly some use cases that we see out there. And we have people who deploy our technology for that purpose. But it's really, in the last couple of years, it's really gotten much broader than that. It's not the general sort of office collaboration which is driving a lot of the demand. A lot of it's got to do with things like customer engagement. So things like being able to have a live video technical support call. So your fridge or your washing machine is broken. You want to be able to get someone on a video call to help you kind of step through that sort of the resolution of that problem. Or maybe it's field services. So you've got someone working in the field on a jet engine in an airport, and they want to be able to bring in 3 experts from different locations and be able to help them to troubleshoot a particular technical challenge that they're working through. We're seeing a lot of work in the financial services space, actually, and there are some very large banks across the globe that are deploying our solution embedded in their stock mobile applications. So our client libraries are embedded in their stock applications, so that when you get into a situation in your mobile banking that you want to speak to an agent, you want to speak to someone who can help you through maybe a tricky mortgage transaction or some sort of higher value transaction, you can click the button natively inside that application and reliably speak to an agent who is empowered to help you through that transaction. And we're seeing a lot of demand rise in that customer engagement space. So that's an exciting area of growth. As I mentioned, field services, there's a lot of work going on in emergency response, field technician support, remote troubleshooting type use cases, lots of work happening there. there is telehealth is another massive area. So obviously globally, medicine with, in a lot of Western countries, there are aging populations. Healthcare in the United States particularly is a constant topic of discussion, spiraling costs, and telehealth is one of the, I suppose, shining technology disruptors that we're hoping will be able to drive significant efficiencies in healthcare. And that's everything from, it comes in lots of different forms. It's everything as simple as logging into a web page, swiping a credit card, and speaking to a GP is one form of telehealth. Another one might be in a hospital environment, being able to take advantage of distributed experts. So if you've got someone who is an expert in a particular kind of heart cardio issue, then being able to bring them in over a high quality connection can really short circuit the care and really improve the care that hospitals and other healthcare providers are able to give their patients. So that's a really exciting area as well. And then, of course, as the last one is the team collaboration, which is sort of the obvious one that we all think about when we think about video conferencing. It's walking into a conference room and bringing in people, having that efficient conversation and driving the business forward. So, given the 10-year context that we're working in, we've released a number of products and SDKs and various evolutions of our technology. But the most recent one is what we're calling Vidyo IO. This was launched as a generally available option in January, and we're seeing some wonderful take up from the developer community, taking our Vidyo IO service and embedding it into their workflows. And Vidyo IO in industry terms, it's a CPaaS, it's a communications platform as a service. So it's basically a set of client libraries that you can very quickly download, embed into an Android or iOS or a Windows or a Mac or a web app, and then add high quality multi-party conversations very, very quickly into the workflow that you already are working within. So it's not like there's a completely separate video app. It's actually embedded into the experience that you're working on today. So that could be healthcare records applications. It could be banking applications, like I mentioned previously. So there's a whole range of form factors that people are embedding this into. So the design goals were really, we wanted to make it as easy as possible. Okay, very simple API. Cover all the platforms, really open documentation, very simple pay-as-you-go pricing model that everyone can get their heads around. The aim was to be able to get developer up and going in about 10 minutes. Download the client library, hit the compile button if relevant, and then you're up and going. So that's what we were sort of looking for in terms of easiness. In terms of reliability, that was paramount. Reliability, and also I'd kind of clip in there security, very, very important. Because of the use cases that we're trying to target, financial services, healthcare, these things, reliability is, I'm not exaggerating, life and death. So let's, really build our infrastructure in a way that is as reliable and as secure as we can possibly make it. So geo redundancy, high service availability, very little downtime, all that kind of stuff baked into the architecture. And you can't kind of clip that in afterwards. You've got to build that into the design as you're creating the platform. And then finally, we knew that we wanted to create a global cloud. We wanted to be the highest quality solution that would work anywhere. So we've got points of presence globally, and we're just adding to those all the time, beefing up links between them, dedicated, sort of backhaul links between our points of presence, and really, we needed solutions, components in that solution that would give us that sort of reach. So yeah, lots of locations. As I said, we're up to 12 points of presence today, and that will be increasing, rolling out over the next few months. As we get demand in particular regions, we're kind of beefing up those. A point of presence for us is basically a number of video routers in a data center somewhere, and then we set up backhaul back into the core of the network. But the vision really here is to be a content delivery network, so a CDN. I'm sure you're familiar with the Akamai's and those sorts of CDNs, but for real-time video. That's what we're shooting for with the Vidyo IO platform. Okay, so the Vidyo IO stack, just to review very quickly, there's the API plane, which is the interface that the developer works to, and it's a very nice, simple API with just some of the basics that you'd expect. Create a call, be able to set up callbacks to listen for people joining, mute and unmute cameras, select which camera you want to use, share your desktop, share an application. Those sorts of things are built into the API. Then there is the first level is there's a signaling plane. And this is where we kind of negotiate the call setup and tear down. We put telemetry through that signaling plane about the quality of the call. We do chat over that line. We do authentication. We do state synchronization, all sorts of things over that signaling plane. So when participants join and leave, that all gets kind of sent over that signaling plane. And then finally, from our perspective, a very important layer is the media plane. And that media plane is where all of the audio, video content gets sent. And we've spent a lot of time kind of optimizing that media plane to work across very, very unremarkable networks. So we evaluated a bunch of different options. We thought when we were creating the architecture behind Vidyo IO, we thought about custom protocols. We thought about lots of different kinds of signaling approaches. We thought about extending SIP, which is a particular it's a common standard. It's a very complicated standard though. It's not one that we felt that we had a lot of experience with. We didn't think it was going to be a perfect fit for what we're looking for. So what we ended up with is actually building the signaling based on the very widely adopted XMPP framework. Okay, so we knew that, all right, we have this, we've got the media stuff pretty sorted out. That's great. We've got a good handle on that, but we need a signaling layer that can really scale to millions, if not tens of millions, maybe even hundreds of millions of online users. That's what we're kind of shooting for. And really, when you set the bar that high, there's only one global stack that would get you there, and that's XMPP. So we end up with something that, this is a simplified view, but something that looks like this. So all the signaling for Vidyo IO happens over XMPP, and when you connect to a call, there's the first thing that happens in an XMPP session is negotiated back to the back end, and then all subsequent kind of media, deciding which, all the geolocation, all that stuff, all the signaling happens over that XMPP channel, and then we bring up the media channel and do all the other things. Now, of course, just to make this very clear, but to an application developer, all of this is transparent. You don't even know that that's what's happening under the covers, and that's deliberately the case. So in other words, by selecting XMPP, we've been able to make it really simple for the end developers. Okay, so in a little bit more depth, we have a cluster of XMPP servers that we maintain for our XMPP signaling, and that's generally speaking over HTTPS, and it's a 443 connection. Pops through most firewalls pretty seamlessly, and so it's we knew that we needed to maintain that cluster in order to be able to create this end-to-end service. And then we have a separate set of what we call, they're actually video routers, but we gave them a new name for the new architecture, and they're called video reflectors. And so these are also a clustered based approach, but they're for the media layer, and they are they're generally co-located with the XMPP signaling, but they're kind of logically separate, and we have the signaling separated from the media. It just makes it a nice architecture to work with. So, of course, when we decided on XMPP, we knew that was what we needed to use in order to be able to get to that potentially hundreds of millions of online users level. And then we had a choice. We had to go out to the market and kind of evaluate and look deeply at what XMPP servers were available. And there are a number of different XMPP implementations, but we needed what we considered a battle-hardened XMPP stack. We wanted to see some good case studies of where this particular stack had been deployed in real anger, and so that was the first test. We wanted something that had been proven to work globally. We needed BOSH support, and that's BOSH is obviously the protocol that's used for layering the XMPP protocol over over HTTPS, and so we needed that. We knew that we wanted to support web endpoints, and therefore we needed some solution to that. We wanted cross-platform support because we've got this broad brush of platforms that we're working with. We needed, rock-solid firewall traversal, and the last point, which I think is also really, really important to emphasize, is that we knew that whatever stack we picked, there were tweaks that we wanted to make. So we really needed to have a responsive team from the vendor who was able to kind of work with us and adapt, maybe make some adaptations to their stack and make it fit our specific use cases. Now, our use cases maybe not, completely typical in terms of the way that XMPP is used, but we knew that we were going to need to have some adaptations made. So that was important as well. Okay, so I guess obviously that's highlighted the what Vidyo.io is. It's very easy to get started, very easy to kind of sign up, and you can go to Vidyo.io anytime you like. Wait until after the webinar, please, but by all means, go and sign up. You get a bulk of minutes for free. You can get started very, very quickly, whether you're wanting to add video into a into a web application or a mobile application or a desktop application. There's sample code, there's API documentation, all that stuff is there, and yeah, so that's the Shameless Vidyo.io plug. So before I wrap up and hand over to Mikhail and back to Mladen, I wanted to say a little bit more about the experience that we had in working with the Erlang Solutions team, and in particular, implementing MongooselM. So we we started off just using the open source version of the platform. And then soon after, in our evaluation process, we reached out to, because we knew that a responsive team was going to be important to us, we reached out to the Erlang Solutions team, and then we actually were able to negotiate kind of an extended support contract. The guys were extremely responsive. They're very knowledgeable about real experts, deep experts in XMPP, and they're able to help us through thinking through the best way of solving the technical challenges that we ran into during the development process. And not all of those were understood, when we first started. It was an evolutionary process. We'd kind of do some work on our side, get so far, and then we needed to kind of have a tight coupling with Erlang. And we found that the responsiveness was terrific. It was really really nothing but positive things to say about the team on the Evolution side in terms of getting back to us and answering our questions, and even like spinning new versions of their software to meet our requirements. So that kind of combination of consulting help combined with architectural support, combined with new software versions was I think that it really meant that we knew that the Vidyo.io service, when it popped out, when we could make it GA, was going to be a reliable and scalable platform, and that was critical for us. So we're really pleased to be working with Erlang. So that's kind of everything that I had to lay out, and I think that maybe we could hand over to Mikhail, and who has more technical depth about the changes that they made on the Erlang side in order to be able to accommodate our requirements.
Okay, thank you. I hope you can see my slides now. And my name is Michał Ślaski. I work as a technical lead at Erlang Solutions Kraków office, where the majority of MongooselM team is located. And I'll try to dive into more detail of what was just described as a MongooselM platform, and also try to give you some examples of our collaboration with Vidyo team. So this is going to be repeated now, but I want to highlight this. This is an open source messaging platform. So all of what I'm just trying to say here is all in public. You can go to our GitHub or website and see the source code. We are quite transparent about our development process, and we publish a lot of new, for example, integration tests. If you go to our GitHub account where the source code of MongooselM platform is hosted, you will find very many end-to-end integration tests, which we run every time there is a new feature added to the stack. and this covers majority of the source code. So this is good because shall you want to extend certain features or customize some behaviors, you always have this reference integration tests that will tell you whether you have broken some behavior or some workflow. We recently also built on top of that concept of so-called continuous integration, where those integration tests are being executed every time you commit a new increment of code, to what we call continuous load testing. So now not only we run end-to-end testing where we say, okay, tests have passed or not, and this is what has failed or were successful, but now we also, every time we commit some increment to GitHub, spawn a cluster of MongooselM messaging servers. We spawn some load generation tools in our private cloud, and we try for a period of time to load test such setup. So we also get feedback in a continuous manner about how performant is this new version of the platform. So this is very good because it, like time-wise, in no cost almost, get a feedback that this new feature that we just submitted was, for example, improving performance, or actually it introduces some issues that can now manifest as higher latency or things like this. So this is a new concept that has been serving us for almost half a year now. It's also done in public. You can visit the continuous load testing website of MongooselM and see that for each pull request, each feature, there is a number of captured metrics, and you can compare and contrast historical releases and most recent ones. We also try to very actively participate in the ecosystem. XMPP is a quite mature protocol. It has been invented in the late 90s, so it's, I think, 18-year-old now. And there is a lot of teams, communities, companies, and libraries out there which leverage the open standard. So the way we try to participate in this relatively big ecosystem is by contributing to the upstream repositories. So for example, if we have improved XMPP library for Android systems, which is called SMAC, we would submit pull requests and changes to the upstream repo so that they can be merged with the main repository, and the whole community can benefit from those improvements. Same applies to iOS library, which is called XMPP framework. There are some applications like Moving, which is about messaging for social network, where we also continue to evaluate and contribute. Jamie, another example of a library for iOS, which helps with some APIs that are used by MongooselM. So this is just an example of a number of projects that the MongooselM team is not necessarily maintaining on day-to-day basis, but we do contribute to those libraries. We also quite actively participate in the so-called XMPP Standards Foundation, which is a body which works on new version of the standard. They expand the existing standard or iterate on some extensions. Our team members are members of this foundation, and we, through active participation, volunteering, and other forms of activity, try to build the XMPP community even stronger. Now, to give you some high level of what this is really, what we are talking about, this whole MongooselM thing, I have a high level view of some components that the platform consists of. I will try to just give you a high level description of each of those components, but I encourage you to dive in by reading our online documentation or through the GitHub exploration if you would be interested in certain aspect of this platform, certain component. So I mentioned already that we have continuous load testing and continuous integration testing. For this, we can see some two libraries in the top left corner, AMOC and Escalus. Those are used for implementing those test suites. Then we have libraries for client side of things. So when you want to implement a messenger application for Android or iOS, you would need a library which connects you to the MongooselM platform, which typically is deployed in the cloud. And for this, we have, as you can see, SMAG and XMPP framework. Those are the open source libraries to which we contribute. Then this is just a library. Library will help you integrate, but it's not the actual behavior, the messenger application itself. So what we also contributed are open source demo applications. We call them Mangosta, and we have one for Android and one for iOS. So Mangostas, they leverage SMAG or XMPP framework libraries underneath so that they can connect to the cloud component of MongooselM platform, but they also implement some messenger behavior on top of it. So things like one-to-one chat or group chat or other features. And this is to illustrate how the whole MongooselM platform could be used in practice. So this can be also forked, used and abused as you see fit. This is not being distributed through any app stores. It's just published as open source repository on the GitHub account. If we look further down, we have the blue square where MongooselM platform is. And in this illustration, we try to indicate that actually there are two distinct APIs that you can use to access the platform features. One is XMPP. This has been already quite well described by both myself and Nicola. But there's also REST API, which for some cases, some projects might be a better fit. And what we do here is we expose through the REST API the XMPP features, and this is quite useful for a number of projects. For this, you will need different set of libraries, client libraries, which is why you can see this reddish or rose squares there with Retrofit and Jamie, two libraries that will help you integrate the REST API of MongooselM into your apps. Underneath our MongooselM rectangle, we can see Wombat.OEM. This is a product of Erlang Solutions, which helps you monitor and maintain a live system. So typically when you deploy MongooselM on some cloud, you would also want to keep an eye on how is it doing. Are there any metrics which we need to keep an eye on? For example, number of online users, number of registered users, number of traffic that is being routed through this platform. So things like this, business level metrics, application level metrics that you may want to observe. And other things also include alarms, log messages, notifications. So anything that you would expect to have in place when a team of DevOps operations need to maintain a live system. This is the use case for Wombat.OEM product of Erlang Solutions here. And there are some also two gray rectangles on the right-hand side, which indicate what is it that we are working on right now, and that will soon be available on our open source stack. One of these components is called MongooselM ICE. This stands for ICE server, which helps with peer-to-peer connectivity, and also quite important, Mongoose Push, which is an implementation of the push notification server, which can nicely integrate yourself with Apple, Google notification systems, and this way you can reach out to your mobile users which are offline, meaning they don't necessarily have your application up and running and like in front of you in the screen, but they have their handsets in their pockets, and you want to send them some notifications that the message arrived, and it might be worth opening your app and then see this message. So this is very important for any mobile app to be tightly integrated with push notification systems, so that you can notify your users even if their devices are not sort of on, as in like opened, that certain messages are awaiting. Now, few words about the global scalability here, because this was mentioned on Nicola's slide. I wanted to give you an example of how we collaborated with Vidyo. So basically, they came to us, as was already said, and they sponsored development of a number of features here you can see some example of those features, but we'll probably not tell you much until you really dive into the specifics of the platform, but just wanted to highlight how this works in practice. So a company like Vidyo is interested in extending the platform with some features which they need, and we work together on making sure that the features will also be beneficial for the general audience, open source community around MongooselM. And then the team has, over the last months or years, was adding those features as requested by Vidyo. For example, dynamic code reload. This is a feature which helps you add and remove tenants to your hosted environment without taking down the whole system, because we reload the configuration of the system live. And other features are listed here. The feature which they recently sponsored is so-called geoscaling. This is something that allows us to deploy MongooselM in multi-data centers around the world. And now clusters of MongooselM could be sitting on 2, 3, 4 different continents, but yet we will be able to route messages cross-continent. So cross-continent routing in a global deployment. And the reason why one would want to have more than one data center is because you can cut on latencies if your data center is close to where the physical location of a user is. So imagine you have users connecting from 3 different continents. Each one of them needs to have short latency towards the signaling server so that the whole negotiation and signaling is as efficient as possible. And for this, it's good to have more than one data center across in the world to facilitate such short latencies. Now, this way of collaborating with the open source team at MongooselM helped Vidyo in long term lower total cost of ownership, because you can see quite a few features listed here in the slide that the team has worked on, and this is just one part of the cost, development. But the second part, which is not always visible up front, is the cost of maintenance of those features. So in long term, now that the MongooselM team is iterating on the platform, adding more and more features that I also will share some highlights of on my next slide, we take responsibility for the features that we already added in the past. So for Vidyo, it was sort of one-off spending to add to those specific features that they had interest in. And now the team at Erlang Solutions continues to maintain and support those features because they are open source, they are part of our stack. In long term, this is definitely lowering the total cost of ownership for Vidyo. And here, a few highlights of where we are today. So if you look on what is next for MongooselM, in Q2 of 2017, we will be adding full text search for the archives. This allows users to perform full text search queries on the history of their conversations. As already mentioned, we will be publishing MongooselM push service, which should allow you to add such a feature to your Android and iOS devices. There are some contributions from our open source community. One of them is JSON Web Token authentication. So this is extremely interesting from our point of view to see that the adoption of MongooselM is already good, and external developers are contributing some new features that we can then review and adopt. So this is great from our point of view, but also nice example of how open source can be powerful. Some more features are listed here on, for example, how we continue to optimize efficiency of this platform when it comes to reconnecting your device, should your mobile network drop at some point. We are also going to describe in more detail our open source MongooselM client applications, the Mangosta, which are already mentioned. So this is some short-term roadmap, just so that you get an idea of where we are. If you want to understand in more detail what is already supported off the shelf, I encourage you to visit our websites, and I'll show you links to those websites shortly. Right, to recap, MongooselM is not just an XMPP server. We consider this to be a powerful platform which can power quite interesting use cases. Messaging or signaling is one of them, as just described here in this webinar. But there are also other interesting areas where such platform can play a significant role and can be your core component, which helps with overall messaging behavior. If you would like to reach out to us, you can do so either on Twitter at MongooselM. You could also visit our GitHub, which I encourage you to do, and click like, give us a star on GitHub. But you can also reach out to Mladen and my colleagues at Erlang Solutions at this email address. Thank you. I will now hand over back to Mladen, and he will moderate our Q&A session.
Thank you for that, Nicholas and Michal, and I'm sure everyone will join me in saying thanks for a really inspiring chat on both topics you covered. Now, as you were speaking, questions were coming in from the audience, so whereas we have little available time remaining, we should still try and answer as many questions as we can. So to start with the first one, can I ask you, Nicholas, specifically, this is a question you've answered partially during the session, but I'd still perhaps ask you to reinforce the point. One of our users is asking, does Vidyo serve to embed video chat into a mobile application such as Android, for example?
Absolutely, yes. So both Android and iOS are fully supported, and the process of embedding is really, really simple. If you've got a little bit of Android experience, then it's basically download a zip file which contains our client libraries. You basically need to just sign up for a Vidyo IO account, and you get an application ID that comes out of that account. So you copy that application ID into your source code. You open that source code up in if it's Android, you're working in the Android Studio, and if it's iOS, you're obviously working in Xcode. You open up in the development platform that's appropriate for the platform. You hit the compile button, and there's a sample app that's built into that sample code. And honestly, within 10 minutes, if you've got a little bit of experience, I'm sure you can get an actual running multi-party video conference going. Now, of course, if you then want to just copy and paste one of those components and put it into an application that you already have, then it's maybe a little bit of copying and pasting, but it should be a very straightforward process. We've designed all of the language bindings are very, very idiomatic. They're designed to fit nicely with the usual programming style on the platform that we're targeting, and so we should really expect that you'd be able to get going in small numbers of minutes for a basic live use case. Yeah.
Thank you for that, Nicholas. And straight on to the next question to try and honor as many as we can. One of our audience, and I think he's not trying to be a devil's advocate, but I think it's a fair question. We're all seeing a lot of video/collaboration tools on the market, and a lot of them are in existence. Many more are being developed. So what would you say, from your perspective, is the key competitive advantage of video when compared to all these mainstream and emerging video communication/collaboration tools?
No, I think that's a very fair question. So some of the strengths that we have as a platform is that, unlike some of the smaller movers, this is not new to us. We've been doing this kind of multi-party collaboration for 10 plus years, 11 years basically, and so we have a lot of experience. We mentioned battle tested. We have very battle tested in terms of the SDK that underpins everything that we do. And some of our fairly public case studies sort of point to that sort of scalability. The Department of Defense, Bloomberg is a big user of our technology. There are a number of top tier global 5 banks that use our technology. So it's the underlying SDK that is it's more focused on that media layer that I mentioned previously, but that stuff has been in development for many years, has been honed, refined, and it's the proof is in the deployment, and it just works much better than some of the newer entrants into this space. We understand how to make it work. And in terms of the technology, there are patented innovations built into the way that we do particularly around the routing of the media, which is, and I'll like just do a 30-second introduction to the concept, but it's a big topic and lots to get into. But when you're dealing with multi-party video, then the old way of doing that was basically bringing all the video streams back at the highest quality you could manage, and then doing some kind of central transcode and a composite centrally, and then sending it out to all of the consumers. So you kind of create a thing that looks like a Brady Bunch screen centrally, and then you send it out to all of the endpoints. That's not the way that video works. Video is multi-stream natively, and moreover, it's what's called scalable video, a scalable video codec. Now, this is a special usage of the word scalable. This just doesn't mean lots and lots of users. This means within each video stream, there are multiple frame rates and multiple resolutions are all smashed together and encoded in that same stream. So what that gives us the ability to do at the router level is make sub-second decisions about, multiple times a second. We're deciding how much bandwidth does this endpoint have, what is the size of the window, how many pixels should I send them, how many streams should I send, or send that particular endpoint. And that kind of that real-time optimization is something that we have we've perfected over a long number of years, and it's something that doesn't really exist anywhere else in the market. And taking that a step further, when we look at that global distribution, the routers talk to each other across large deployments. And a nice visualization of this, if some of our attendees Google CERN, C-E-R-N, as in the European Physics Research Institute, Vidyo, our spelling, V-I-D-Y-O, dashboard, then you'll find there's actually a publicly accessible dashboard which shows the video deployment in CERN and where all the routers are and where the conferences are traversing. And you'll often see that there are conferences that are spanning multiple countries, multiple continents. We're getting great aggregation of media traffic. You're not having to backhaul. If you've got 25 or 50 people on a call, you're not sending 50 streams 50 way, 50 by 50. That kind of mesh is unsupportable. And so having that routed infrastructure where it's intelligently making decisions about what to send where is critical for creating a really reliable, scalable experience in the video space. And so that's why I'd point to Vidyo. And Vidyo just is the apotheosis of all of the development that we've done over the last 10 years. It's the simplest APIs, but it has the most advanced SDK underpinning those APIs.
Thank you, Nicholas. I would say a comprehensive and certainly a compelling. Like I said, honor as many questions as we can. Let's move on to the next one. One of our audience members, Almas, is asking, what is the limitation on the number of participants in a session?
There actually isn't a hard limit. So we'd expect that it should work up to thousands, potentially. There's no reason why it doesn't. And that's in a single conference. Okay, across multiple conferences, it's millions. But in a single conference, thousands we think is practical. In terms of actually showing the number of tiles on a screen, that kind of depends on the amount of network bandwidth and the amount of compute that you have locally. We can quite often see 16 or even more, 20, maybe even more tiles than that on a single screen, or spread across multiple screens. We have one extreme example is of a deployment that we built in India, where the use case was a CEO of a very large organization there wanted to have a Monday morning staff meeting with all of his branch offices, and there are 960 branch offices, and he wanted an entire wall painted with real-time video So every one of those 960 offices appears as a square on this massive video wall every Monday morning. So he can kind of survey the enormity of his empire, I guess, but it works. It works nicely, and that's enabled by our technology.
That's really interesting, and thank you for that, Nicholas. Now, the problem we have, and that happens regularly in our webinars, is that we're receiving questions at a faster pace than we're answering them. So just to say that we'll answer as many questions as we can right now, and then all the unanswered questions we will answer in writing. So if you've asked a question, rest assured you will get an answer. But just to move straight on to the next question, if that's okay with our speakers. So this is a bit of a longer one, so I'll try and read. Gary is basically saying, we used to use VNC for collaboration, which was effective as you could share control of mouse or keyboard, as well as just screen video. Now, conferencing systems that Gary has used since do not really support this, and that makes true collaboration clumsy. So he's asking, what would it take to support this in your or other similar systems?
Yeah, that's a fair question. So just to be clear, our solution today allows you to share computer content into a conference. It's not just video content. It's not just looking at me. It's not just a camera, but it's also you can choose programmatically. You can choose a window or a whole desktop to share into the conference, and that works really nicely. We've got some clever codec engineers who have optimized our video experience in order to support that computer-generated content very efficiently. So that's supported today. So that's half the story. The second half of the story is kind of the control information sent back in the opposite direction. So I can see your desktop, but now I want to interact with your desktop, and that's something that we'll be adding to the Vidyo platform in the coming months. So it's something that will be there as part of the solution, the ability to kind of send those control messages back and kind of control or interact with an application running on that far side. So that's where we are today.
Yeah, thank you for that. That makes a lot of sense. Now, on to the next question. One of our audience members again is asking, do you rely on some type of a open source platform for media handling?
Generally speaking, no. The only caveat to that, so like the bulk of the video experience is created with the Vidyo SDK, which is close to 2 million lines of tightly optimized C code. It's something that we built from the ground up and have honed over many years. The only kind of exception to that is in some modern browsers, there is a technology stack that people might be aware of called WebRTC, and that's built into Chrome and Firefox today. Edge from Microsoft is close to having WebRTC compliance. It's not all the way there yet, and we know that Apple is working on it in Safari. So in the browsers that support WebRTC, we can use WebRTC, and we will use WebRTC for the media handling. It's nice. It has an upside in that it doesn't require any download. It can just be you can just use it natively in the browser. The downside is it's nowhere near as optimized as the Vidyo SDK. So the quality is not quite as good as what you would get using the native SDK. And of course, in a lot of mobile environments where that's really, really important, people tend to use our client libraries, embed them in a native app and kind of download that as the means by delivering that Vidyo SDK onto the client for use. So generally speaking, no. The one exception is the WebRTC client side.
Thank you, Nicholas. Now, I'll have to apologize to our audience members, but given the available time, we can take 2 more questions. So I'll move on to the next one, and then all the other questions will be answered in writing. So the next question comes from Tore. And Tore is asking, is there any support available for client-side AngularJS integration, which can be used on desktops as well as handheld browsers?
Okay, great question. What I'd say is that the JavaScript bindings for Vidyo.io are actually of a form that are kind of framework agnostic. They don't really care if you're using Angular or React or Vue or Riot or any of these kind of funky frameworks. Effectively, in the JavaScript world, what you're doing is you create, however you want to create a div element in your DOM, and then when you initialize the video client library, you point it at one or more divs, and we'll fill those with video. Okay, now you can either choose to say, video, you manage the composition of what goes into the div, or if you want more control, you can say, I'm going to kind of lay out the divs as I want them to be, and then as new streams come online, I'm going to set up a little callback, and I'm going to feed those streams into the divs that I choose. The simple composition, or you can kind of have full control over what gets composited. Now, Tori also mentioned handheld browser. It's a qualified yes for handheld browsers. On Android today, Chrome Mobile supports some amount of WebRTC functionality, but it's certainly not optimal when you compare it against the work that we've done in our client libraries. So if you're that you want really high quality video, I would nudge you towards using our client libraries. And that's because we've done lots and lots of work, down to hand optimizing assembler, SMID instructions, really understanding deeply how the ARM architecture and x86 architectures work to get the best, the highest efficiency in terms of encode and decode of video. And it's a really specialized piece of optimization to make that work. And that matters a lot in the mobile environment because you care about battery life and you care about quality, without chewing up a lot of CPU. So yeah, if you're doing serious work, I'd suggest the native client approach is probably the best approach still in the mobile space.
Thank you for that, Nicholas. And we'll have to take a final question. And I would just like to say again, we'll answer all the questions that have not been answered in writing, and also to say that we are answering these questions in the order in which they were received. So obviously asking a question early helps. But just to ask the final question, and I think you've already addressed this during your presentation, Raul is asking, can Vidyo.io be used for live audio?
Yes, the answer is absolutely yes. So we send both audio and video. We have callbacks for selecting the audio device that you want to capture and kind of input and output of audio. We use the Opus codec, our own implementation of the Opus codec, which is a very highly efficient audio codec, high quality for sending audio through the conference. So yes, it's absolutely supported.
Nicholas, thank you for this, and Michal, thank you as well. Now, I'm sure that everyone who's taken part in the webinar will join me in thanking yourselves for a really inspiring talk on Vidyo's work and on MongooselM. Many thanks to all of you who have joined us for the webinar, and please join us again for our next monthly webinar. Now, following today, we will send you a short survey just to make sure we capture your feedback of today's webinar. Please also note that the recording of this webinar and the presentation that was shared today will also become available for you to collect and view on Erlang Solutions' corporate website at www.erlang-solutions.com. Now, thank you all once again, and we look forward to seeing you on our next webinar.